Is it stopped? Sorry. Yeah. Okay, I would like to begin with a question based on the fact that both of our presenters have a lot of experience with rainbow trout farming in Ontario. So first question to Professor Dominique, maybe you can share some light on my first query, and then Mr. Roy or Jordan will add some other perspective from their field. So my first question is, how much do rainbow trout farm in Ontario rely on technology today compared to the early days of the industry? Or maybe you can make some comparison based on provinces, actually how this Ontario province and rainbow trout farming in Ontario progressing in terms of digital technologies. Yeah, Professor Dominique.
Well, we have a lot of participants from the industry. I think online I see a number of highly experienced industry professionals online, so I don't want to take over the things, but I think, I mean, there's been a lot of evolution in our industry today from the early days in the the late 1800s, where trout farming or salmon farming started in Ontario, up to the 1970s, where hand feeding was a thing. The feed quality is very poor, and the breeding technique is very different. I think we're using more modern technique. We're using more equipment. You go visit aquaculture operations, and you see a whole bunch of equipment that did not exist before, from fish pumps to egg counters, egg sorters, and the like. So I'd like to actually open up the discussions if anybody is has an opinion about that, whether we've come a long way, I guess, in terms of evolution. One of the things that I see is our industry, maybe because it's too small, is relatively low technology or basically homemade technology base compared to farms that I visited in Chile and other places, which are a lot more reliant on technology.
Yeah, thank you, Dominique. Maybe Mr. Roy or Jordan, would you like to add some comments on this question?
Yeah, as far as the advancements in technology goes, you know, we think the auto fish feeders are one of the biggest things that has come into play over the past 20 years. And I mean, in that short time, it's the amount of feeders and farms that have adapted these new technologies into their farms. You know, it's been really good to see.
What kind of market penetration do you have, like roughly when you visit farms? So is there a majority of farm using automatized or some type of mechanized feeders today?
Yeah, I'll comment on that. The larger farms, the salmon farms, are pretty much all on the automated feeding systems. It's just taking a little longer to get some of the smaller operations. But if you've seen in Ontario, there are dramatic improvements in conversion rate now, FCRs, and significant savings in labor too. And the reliability of the systems, it's a great improvement over manual feeding.
Great.
So the return of investment must be very good, given the price of feed and price, of course, of labor and the saving that you can get in terms of FCR.
Yes, and I'd say you're looking at paybacks 1 to 2 years in most applications.
Oh, that's good.
Yeah, great. So we have a hand raise. Maybe, yeah, you can open up your camera and ask question directly, Mr. Firoz Alom. Yeah.
Thank you, Human. I'm just a little bit under weather. I'm not in my best shape. Thank you, Professor Bora, for your excellent presentation, and thank you, Jordan. I was wondering, particularly in terms of adopting artificial intelligence or the exponential technologies in the agriculture, precisely speaking, like precision agriculture. So I have a comment and then curiosity or question. If you, like you have mentioned that in other places like Norway, the adoption of these technologies are higher compared to in Canada. Given that we have GDPR at the moment, to what extent the systems in Canada can be trained based on the data that already exist in places like Norway? If they have been doing it for some time, can that data be used for training our systems, AI models here in Ontario to develop a system which is better efficient. And then the question comes in terms of, the data governance, who owns the data? Can you bring it? So what's your observation on that?
Sorry, I mute myself. Yeah, that's a bit of our bread and butter with the Aqua, where we're trying to implement modern technique and modeling, and including machine learning technique in doing this. There's two things. I mean, machine learning is not the panacea to everything. So it assumes, very often we assume that the data contain all the answers, and they don't necessarily contain all the answers. Second of all, we assume that the machine will know better, whereas there's a certain way basically the world works, right? So we have 500 years, 600 years of modern science to analyze the information. So the first step is actually gathering the data, structuring the data. And a lot of it in Ontario is a lot of manual-based data, enter data, control feeding by hand, etc. So it's not like in the case of, let's say, Norway, where there's going to be a lot of mechanization, a lot of data compilation already. So that's one of the hurdles that we see. But definitely there's a great role for machine learning. But I think it's going to be in trying to link, a bit like what Mr. Hines was saying. He says, well, we've got improvement in FCR, and it's related to this. So trying to relate different factors, whether feeding level, temperature, feed distribution pattern, weather, and all these things, and associate this with feed utilization. I think that's where machine learning will be the most powerful in that thing. And then from an Ontario perspective, what we found with work that we did with the Department of Fisheries and Oceans, Freshwater Institute, is that it was very difficult to predict environmental changes and environmental waste associated with very precise amount of waste estimate in a very small environment. So imagine you are operating in Georgian Bay or North Channel, and how can you really predict? So basically, a lot of cases made about potential impact of aquaculture, but very little true data, true insights is there. So I think this is where advanced computation technique will be able to objectively assess what could be some potential environmental impact or changes associated with changes in fish culture. But that's one of the aspects.
Yeah, thank you, Professor Burrow. Yeah, and in terms of, I mean, my doctoral research looks into that. What are the socioeconomic factors that influences the adoption or denial of agrobiotechnology, given the current situation of growing distrust in public institutions and scientific bodies because of a lot of things, and obviously a compromised information ecosystem. You mentioned at one of the slides, you talk about that how this data can actually inform advanced research in genetics, in terms of like, I was reading a paper that, some people are looking into how the climate change and preemptive genetic guarding can actually help maximizing the production of yields in cattle. So what kind of data that we can gather from this advanced system that can actually contribute in some kind of GMO research, given that GMO does not have a very positive perception generally around the world?
Yeah, just setting aside the GM modification, just conventional breeding, there's a lot of work that needs to be done, that can be done in this field. You talk about cattle, and I got my early starting career in dairy genetics, and I saw how the entire dairy industry globally, from US, Canada, Europe, is compiling data and using the most advanced mathematical model, statistical model, breeding model to estimate everything and make great stride. And that's been always my motivation for applying this kind of approach, or I've been always motivated to apply this kind of approach to fish culture and genetic improvement to basically really truly determine the impact of genetics, and then this all interaction between environment and genetics, right? We have very different culture environment. Do we have the right genetic? How do different animals differs vary? How can we predict what kind of traits we're going to need in the future? How to develop selection index? I think it's going to be important. And that's all starts with good data. It all starts with good models to describe what the animal is truly doing and organizing that information for sure.
Thank you, Dr. Burrow.
Yeah, thank you very much, Mr. Alo. So my next question is to Mr. Jordan or Mr. Roy, because they're from the tech company and they are working on feeding system management or development. So I would like to know actually that as a technologist, do you believe that the adoption of feeding system is quite satisfactory at field level? Or have you had difficulties in disseminating your technologies within farming communities? What's your experience actually? You are muted, Jordan.
Technologies.
Yes.
Not really. It's been pretty straightforward.
Yeah, there hasn't been since the beginning, there hasn't been too much adapting in the technologies, but a bit, right?
The main thing is getting the daily rations bang on. You don't want to be underfeeding, you don't want to be overfeeding. So you have to keep very careful track of your biomass, your average weights and quantities.
Mhm.
And if you have that nailed and you have your distribution appropriate, probably 80% of the tanks, it's pretty straightforward.
Okay. I don't know, but maybe Professor Dominique, from your experiences, could you also comment on this? Could you like to also comment on these points?
Yeah, I mean, it's exactly it. So controlling the ration is important. Now, what to determine what the optimal ration is based on the potential of the animal and the composition of the feed is, right? And the prevailing conditions. In a land-based system, it's quite a bit more stable. In a natural habitat, in a natural environment or outdoor, it's quite a bit more variable. Getting that ration accurately computed or forecast, it can be really quite challenging, especially in a context where you don't have that good of an idea of the biomass, the standing biomass, the exact size of the animal, the exact need of the animal. And we've been working on developing the know-how and model. But again, it goes back to having the data and having that feedback loop. So system that what Norcan is developing is great because it's computerized. You have the data, you have this, and we can link this with proper data on the animal itself and the farm themselves. And I think we've got a winning solutions in terms of linking the inputs and outputs and trying to find these association, what factors are important and how to adjust the rations.
Yeah, great. So we have one question in the chat box. Maybe I can read it for both of you. Thank you for a great presentation. It was mentioned that many of the companies selling hardware have software included. The question is there strategic work being done to work collaboratively with technology developers to include common standard within the technologies that would allow for the generation of data that has used similar metrics to make data analysis easier? This is one question. And maybe the second question, I can just narrate it. What is the comparative level of difficulty or is with the incorporation of technology by larger versus smaller farms? And what are the main factors that deter or slow the incorporation of technologies? So a lot of things, but maybe one by one we can talk about. Maybe with the first questions, maybe Dominique or Jordan, you can just leave your comments there. Yeah.
Yeah, in terms of that's an excellent question, and it's been one of the focus of my research program. One of it, for example, is the expression of growth rate, given the fact that temperature is variable, that the initial final weight of the animal. So in the old days, and still today, I still see people using specific growth rate, which changes as the animal is growing, change with temperature, so the development of basically robust growth index, like the TGC model in this case, which has a number of limitations, but is still really quite reliable. The adoption of this measure of growth by the salmon industry especially has been really helpful to create the same language, the same culture, the same basis of comparison. So you can start comparing benchmarking performance. So you have a TGC or GF3 that's called known in the salmon world, where you can determine what is good performance or not. But that's one example. And we've been working on developing similar models, similar growth index, robust growth index applicable to tilapia shrimp, barramundi, and all these other species that are cultivated around the world. So I think it's an important aspect. Like I said, several systems will compute the same parameters in different ways. For example, biological FCR will be completed in different ways, and then sometimes using farm inputs which are biased. So therefore, this is so. Sometimes some of these kind of basic terminology or basic computation is really the starting point to have a useful collaborations between different things. So
yeah, thank you. Maybe the second one, maybe you can also add some comments on that. Is there any difficulties incorporating technologies within larger and smaller farmers? Because obviously, there is obviously differences between these two categories of farmers. Some large farmers, they have maybe more capacities, and the smaller farmers, they don't have.
Exactly.
Yeah.
I think Roy addressed that in previous answer.
Yeah.
I mean, all the big guys, all the big farms on the West Coast and Chile and Norway are all automatized, whereas the small one is been things. It's a return on investments, the ability to invest in capitals, the time and things, whether it's worth or not, right? Sometimes you just say, well, we talked to some farms in Latin America, for example, it says, well, yeah, I could be investing in technology, but having somebody, I can pay somebody to do the work, and if I need help on a do something else, the guys there was the technology cannot help me. So that's the other kind of the other aspect of this is having the right fit and the right price. So definitely adoption is determined by size and means and socioeconomical conditions for sure.
Yeah, thank you. Maybe the next question is for I think Jordan. One of our participants just posted this question in Zoom chat box. Does the automated computer control feeders cited in your presentation take into account the concept of precision nutrition in order to provide the right amount and quantity or quality of feed for each stage in fish? I have seen this practice applied in other species like swine or in animal sectors. Yeah, maybe Jordan, you can just comment on this question.
So Roy's going to comment on that one in a second here, but I just want to touch up on the collaborativeness, right? So there isn't a lot of collaborativeness right now with technology developers, but there could definitely be a lot more to improve these farms and work together and such, right?
Yeah.
For sure, I definitely do think that. And I'll leave this next question up to Roy here.
Yeah, I think what Jordan's getting there is, and I think Dominic did, is standardizing databases a bit more and make them more interchangeable. That'd be a big help. As far as the next question regarding feed conversion, the auto feeder AF8 system uses various tables to keep track of FCRs based on temperature, average weight, and specifically the type of feed. So depending on what feed goes out, and if you made your ration for that day or you're under or over, it'll adjust the conversion rate accordingly, grow the fish the appropriate size, and increase the feed for the next feeding. So there's a little bit of, I guess you call it artificial intelligence there, some algorithms, but yes, it definitely has all those requirements.
Yeah, thank you, Mr. Roy. We are running out of time. It's already 1 hour. Maybe the last question, but it's out of the presentation or out of the context, but it's relevant with our enabling environment for adoption of digital technologies. I would like to start with Dominique. So what would you change if you were appointed as a Minister of Agriculture and Agri-Food today to foster a supportive environment that would bring about changes in rainbow trout farming in terms of digitalization in Ontario? What would you do as a minister?
Well, I think at this kind of discussion, broader discussion, bringing the industry, the people basically feeding the fish and producing the fish on a daily basis, the technology providers and preferably perhaps Canadian technology providers. We got wealth of technology company here in Canada. We could do homegrown, and then other industry stakeholders, and have more discussions on how to create a more productive industries and how to improve the productivity. Sometime, I mean, the solution is technology. Sometime it may be other hurdles. So it's important to address that.
Yeah.
So that's what I would do if I
Yeah,
was
thank
ever
you,
going in
Dominic.
politics.
Yeah, maybe Mr. Roy, would you like to comment on this? Because you are also experienced working in this field over the last 30 years. You have a lot of experience. And if you are appointed as a Minister of Agriculture and Food today, so what would you like to do to bring a change in rainbow trout farming in terms of digitalization?
Okay, I think you're on the right track with this webinar. Make the farmers in the lakes there more aware of the technology that's available for centralized feeding, automated feeding, and the benefits. I know they're going to see significant improvement in the FCRs like we talked before. And yeah, I'm glad to see you're moving forward with this.
Yeah, there's we love to see these farms have the feeders and just have less hassle and work on their hands, right? It's really nice, right? Like when feeders go down, it's oh, we have to hand feed, right?
Exactly.
But yeah, no, it's good. Very good. Yeah, this webinar is good to get around and talk and meet up with everyone. So thanks for having us.
Yeah, thank you. Actually, this is the starting. We want to continue our discussion in future. We want to know about this farming industry, rainbow trout farming, so that we can provide some insight or some policy that, yes, how you could bring some changes in this industry regarding enabling environment. So we are at the end of our webinars. If we have no further questions, I want to thanks to our speakers and every participants who came out and spent their valuable time with us. I also want to thank Mike from OMAFRA and Professor Chaudhary for helping me with organizing this webinar. I hope we can meet soon for another webinar to continue our discussion. I would like to also request all of the actors from rainbow trout farming sector in Ontario who are joining our today's webinar to support us in future while we send out a brief survey. So please cooperate with us. We want to work with you. You will also receive an email containing a link to this webinar so that you can watch it later in your free time, or you can share it with someone who might be interested. So that's all from my side. Thank you very much for your attention, cooperation, and we hope to see you soon in our next webinar. Good afternoon and bye-bye.
Thank you. Goodbye.
Bye, everyone, and thank you.
Bye, everyone.
Goodbye.
Thanks again for putting on the presentation.
Thank you, Jordan, for joining us. And
Yeah,
also
we'd love to talk again in the future.
Yeah, obviously,
with
we
you
would
guys,
also
so-
love to connect with you in future, obviously. Yeah, have a
Thank
nice day. Yeah, take care.
Okay,
Bye-bye.
bye.